that has only one point of contact with the circle. It lies perpendicular to the circle. Alright, we have to prove here that tangent at any point of a circle, this tangent will be here, here, anywhere on the circle, it makes an angle of 90. That is, it is perpendicular to the radius of the circle. As you can see, this line OP is the radius of the circle. Now what are we given? We are already given in the figure, as you can see, x, y, it is a tangent touching the circle at point P. And we are supposed to prove that this radius OP is perpendicular to x, y. Now let's begin the proof. In the proof we'll write, suppose if we take a point Q on the tangent. So write, take a point Q on xy and join OQ. Alright. Now, if you see here, this point Q must be outside the circle, because if this point lies inside the circle, then we will see that this xy will become a tangent, sorry, a secant. Alright, what I want to say is, if I mark this point Q, if I have taken this point Q inside the circle, then I would have drawn this tangent, but it would not be a tangent, it would have been a secant. Alright, so here we see that OQ distance is larger than the radius OP. OQ is larger than OP. You can see this distance OQ, that is the Q point lies in the exterior of the circle. It cannot lie inside the circle, because then it will not form a tangent, it will form a secant. Alright, thus we can say that the distance OQ, you write thus here, thus OQ is greater than OP. Okay, so we can say that this is true, this concept which I just proved, OQ is greater than OP. Okay, this is true for every point Q. For every point Q on xy other than which other point is lying on the tangent? P. Alright, so we can say that here OP is the shortest distance. Here OP is the shortest of all the distances, shortest distance. Okay, as you can see from the figure, so we can say that OP is shortest distance, hence we can say that OP is perpendicular to x, y. Hence, this marks the end of the theorem. Hello friends, welcome to this session. Okay, in this session I am going to teach you the concept of circles, chapter number 10, standard 10. So before we start the exercise, let's begin with some basic concepts about circles. Okay? Right. So very first thing is, let's talk about a circle. We draw a circle. What is a circle? I want to dictate the definition of circle and then you will write it. So what is the definition of a circle? A circle is a collection of all the points in a plane. Here we can consider the blackboard is a plane. Okay. These points are at a constant distance from a fixed point, that is at the center. As you can see, all the points of the circumference circle are at a fixed distance or constant distance from this fixed point at the center. Okay, so I repeat the definition of circle once again. A circle is a collection of all the points in a plane which are at a constant distance from a fixed point, that is a center. Alright, after that this, we'll go through three basic concepts relating to a line and a circle. Line and a circle. Now, suppose we have a line and a circle, and the line, there are three possibilities actually. There are three possibilities when a line and a circle are given in a plane. Number one, the first possibility is the line and the circle do not touch each other at any single point. Let the end points of this line be P and Q. Okay, so you can see here the first possibility, when a line and a circle are given, then we can say that this line PQ and the given circle have no common point. They don't touch each other. Alright. So this we can say that this particular line is a non-intersecting line. Now, the second possibility is the line can touch the circle at two distinct points. You can call it a chord as well. Let this point be Q, let this point be P. Alright. So what do we see in the second case? In the second case we see that the line PQ and the given circle have 2 points. That is, the line touches the circle at point A and point B. So P and Q are the endpoints of the line here. Right, so you can say that the line PQ in this case is a secant. Alright, now the third possibility is, when you talk about the third possibility, we can say that in the third possibility, the line touches the circle at a common point, and this line is at a perpendicular distance from the center of the circle. So let this line here, let it be indicated by P and point Q, and the point at which it touches the circle is point A. Let the center of circle be O. In the third case, what do we see? That is, there is only one point A which is common to the line PQ and the given circle. Okay, so we can say that when a line touches the circle at one common point, that line is termed as the tangent to the circle. So here we finish with a few possibilities of a line and a circle, and I am going to dictate you a few points. That is, you should remember there is only one tangent, okay, at a point of a circle, as you can see here. At a point there is only one single tangent and no other tangent. Second thing, there are many points on a circle, as you can see. Alright, so through a point lying on the interior of the circle, we cannot have a tangent to the circle. What does it mean? It means that if a point is lying on the inside of the circle, then you cannot have a tangent passing through it. It will be a secant. Next is, through a point lying in the exterior of the circle, we will have exactly two common tangents to the circle. Now what does it say? This point says that if I am given a circle and a point lies on the exterior of the circle, neither on the circle or inside the circle, then from this point P, from the exterior, two tangents can be marked on the circle. Well, now one more thing to remember from here, that is, there cannot be more than two tangents parallel in a given secant. Now if you see here, this point dictates that if you are given a circle and a secant, if you are given a circle and a secant, then only two tangents will lie parallel to this particular secant. This is the secant, that is tangent 1, that is tangent 2. So we need to remember these concepts. Alright, let's begin exercise 10.1. Look at the first question. The first question asks, how many tangents can a circle have? So I already explained you this concept, that first of all, when you talk about a circle is set of all the points equidistant from a fixed point. Alright. Now when we talk about tangents, we know that a tangent and a circle has only one point of contact. So you can see here, a circle, there can be infinitely many tangents to a circle. I am drawing it with the help of a circle and a line and showing you the point of contact. You can draw as many tangents. So in short, I would say that you will write the answer as infinitely many tangents. Now, let's move to question number 2. We have fill the blanks in that. Question number 2. I'll explain the concepts with the help of diagrams. Let's see, the first one, a tangent to a circle intersects at dash point. Now, let's see, we have a circle and we know that a tangent has only one point of contact to a circle. So we can say that a tangent to a circle intersects a circle at one point. This is the answer. Now let's move to the second line. In the second line, the question reads, a line intersecting a circle at two given points. So let's draw a circle. When a line intersects a circle at two given points here, we know that this sort of a line is termed as a secant. Let's move to the third sub question of question number 2, exercise 10.1. The third sub question reads that a circle can have dashed parallel tangents to a secant. So let's see, let's draw a circle first, then let's draw a secant. Now how many tangents can be drawn parallel to this secant? I write a secant here. So first tangent on that side to the parallel to secant. The second tangent will be on the other side. As you can see, a tangent is only one point of contact. Let this point of contact be O and P. So the answer to this question is a circle can have two parallel tangents. Now let's move to sub question number 4 of question number 2. The common point of a tangent to a circle and the circle is called. So you can see, let's draw the circle first. Let's draw the tangent. So the question is that this common point, this one, the common point of a tangent to a circle and the point of the circle, this is termed as point of contact. Now let's move to the next sub question, that is not sub question but main question, question number 3. Let's see, in question number 3, what does it read? We are given that a tangent PQ at a point E on a circle. So let's draw the circle first. Let's draw the tangent. Okay, so point of contact is P, the tangent is PQ. Let's read further. Of a circle of radius 5 cm. Now from a fixed point, let this point be O. The radius of the circle is 5 cm. Let's mark the radius with a different pattern. Alright. Now, meets a line through the center at a point Q. As you can see, a line drawn from O to Q. Okay, the measurement of this line is 12 cm. Now, we are supposed to find the length PQ. We have to find this. Now, as you can see, this figure forms a right angle triangle. So, when we talk about a right angle triangle, then we utilize the Pythagoras theorem. When we utilize the Pythagoras theorem, then we know that the concept to find the base of the triangle is base is equal to under root of hypotenuse square minus altitude square. Let's replace this formula with the values from this particular triangle that we see. So the hypotenuse given here is OQ, the longest side of the triangle, minus the altitude is the perpendicular, that is OP. Let's replace the values for it. OQ is 12 whole square minus 5 whole square, that gives you 144 minus 25. When you subtract both these values, you get the answer as under root of 119 centimeters. Alright, so the sum is solved and you can write lastly that the base PQ is equal to under root of 119 centimeters. This marks the end of this sum. Alright, now let's go. So you can see that in the question you are given options. Among the options, option D is the correct one. Now let's move to question number 4. The main question, question number 4. What does it read? Let's see. Question number 4. In question number 4, we are supposed to draw a circle and two lines parallel to a given line. Okay, so let's draw a circle first. Draw a circle. Let the center be O. Now after drawing the circle, we have to draw two lines parallel to a given line such that one of the line is a tangent and the other is a secant to the circle. Alright, so let's see. We have already given a line outside the circle. So this is the line we have. Let us mark it as L. We have to draw two lines parallel to this line. One of that line will be the tangent to the circle. Let this line be M. And the other line will be a secant to the circle. I'll write here secant and I'll write here tangent. This is line N. So here you see this line L is the given line, okay, and M and N are the lines parallel to this line L. So you can say that line M is a tangent to the circle, okay, and it touches the circle at point P. Let this point of contact be point P, and the other one, line N, as you can see here, is a secant of the given circle, intersects the circle at two different points, and those points can be marked as A and B. This marks the end of the exercise 10.1. So friends, we are going to meet very soon with exercise 10.2.